All right, so for this one, I decided that we'll actually do two more problems, not just one more problem. So here's our first example. We do have two variables. We are going to want to combine them. You could make them to where they have like denominators and then combine them, but I like to do the whole let's get rid of fractions. So my LCD in this case, I have 7, 2, and 42. So my LCD is going to be 42 because both 2 and 7 will divide into 42. So I'm going to multiply everything. So far we haven't worked with many whole numbers. That includes all whole numbers are going to be multiplied by our LCD. So again, LCD 42 because that's what 7, 2, and 42 will divide into. So when I'm thinking of this, I'm going to take this 42 times 10/7. In my head, I am doing 42 divided by 7, which is 6 because after school my brain's not working. 6 times 10 gives us 60. So this is 60x. And then I'm going to take 42 times, the negative's going to stay, right? So 42 times 1 is 42. And then I'm going to take the 42 times 9/2. And half of 42, right? 42 divided by 2 is 21. And then I'm taking that 21 times the 9. So I took 42 divided by my 2, and then I'm multiplying that answer by 9. And we are coming up with 189. So plus 189x equals, and then 42 divided by 42 just divides out and leaves us with a negative 457. Because those will divide to 1. From here, I have like terms, right? 60x and 189x. When I add those together, because they are on the same side as the equal sign, right? Here's my equal sign. If you need to, draw your line, right? Draw your line. They're on the same side. We combine. All right, so I have 249x minus 42 equals a negative 457. From here, two-step equation, so I'm going to add 42. That light looks like it's maybe just glaring instead of actually helping our, oh, not what I wanted to do. This is part right. There we go. There's the lamp button. There we go. It's darker, but we'll just deal. I'm going to add 42 to both sides. Because this one's negative and that one's positive and the 457 is bigger, I know I'm going to have a negative answer. And because they are different signs, we're going to actually subtract. But 415 minus 42 in my head is 415. Or with a calculator, because I wasn't expecting these to be this large. 249x will equal that negative 415. From here, we are going to divide both sides by 249. I know that x is going to equal a negative, because I have a negative divided by a positive. And then we got to figure out what we're going to divide both of those by. And trial and error. I know that that's 83. And so I know that negative 415 over 249. When I divide 415 divided by 83, I'm going to end up with 5. And 249 divided by 83 gives me 3. And that's our final answer for that problem. Woo! All right, we do have one more. It'll magically appear on the problem or on the board. All right, the last example I'm doing in the videos. You may have made it this far, you may not have, but there's a reason why I have this one. It is because it is a special situation, and you will probably figure it out when we get to the end. Again, I'm going to look at my denominators. I could over here go ahead and combine all three of these that are constants and not coefficients. They are like terms, but that's a lot of fraction work. So I'm going to look at my LCD. I have 7, 21, and 3, because that's another 7, right? And 7, 21, and 3. 21 is our least common denominator. So I'm going to multiply both sides by 21. So I'm going to take that 21 times the 1x, and I'm going to get 21x. I'm going to take the 21 times 10 sevenths, and I'm going to think of that as 21 divided by 7, which is 3. And 3 times 10 is 30. So now I have plus 30. And then that is going to equal, and then over here I'm going to take 21 times a negative 29 over 21. The 21s will cancel out, right? They will divide to 1. So I'm going to be left with a negative 29. Plus, I cannot forget that I need to take this 21 times my 1x. So I'm going to now have 21x. And my computer cord is now getting in the way, but that cord goes to the projector, so it can't go away. Now we're going to take that 21 times 15 sevenths. So 21 divided by 7 is 3. 3 times 15 gives us 45. And then finally, 21 times 2/3. So 21 divided by 3 is 7. 7 times 2 is 14. So that's where I am. From here, I have no like terms on this side. If it helps, draw your line, right? No like terms on this side. Over here, we have negative 21, 45, and 14. So, typing it all in, I will say, I have sticky notes with everything on it. It is definitely an after-school moment because I already solved this entire problem, but forgot to hit record. So here I go again. 8th grade? Well, let's try this one more time. You didn't get to hear my awesome first take. Alright, with this problem, I could go about, I do have 3 like terms. If I wanted to combine them, you could. I want to just get rid of all fractions. So when I'm looking at my denominators, I have a 7, a 21, a 3, another 7. So I'm looking at what is the LCD for 7, 21, and 3. And my least common multiple, or my least common denominator, is 21. So I'm going to multiply 21 through the entire equation. So remember how this works. I'm going to take 21 times x, and now I have 21x. I'm going to take 21 times 10 sevenths. So I'm going to think of it as 21 divided by 7 is 3. 3 times 10 is 30. So that's what I have on this side. Equals. I'm going to do the same thing over here. Negative 29 21st times 21. The 21 and the 21 will divide out, and I'm left with just a negative 29. I do need to make sure that I take that 21 times that 1x and get 21x. And they're going to take 21 times 15 sevenths. So I'm going to think of it as 21 divided by 7 is 3. 3 times 15 is 45. All right, and then I'm going to take 21 times 2/3. 21 divided by 3 is 7. 7 times 2 is 14. From here, now, if it helps, you can draw the line in between. This side, I have nothing to combine, so I'm just going to bring it down. This side, I have a negative 29, a 45, and a 14 that are all like terms and can combine, but I'm going to go ahead and bring up my 21x because there's nothing for it to combine with on the same side. I'm now going to take negative 29 plus 45 plus 14, or 45 plus 14 and then subtract 29. Your choice on how that works, but when you do that, we end up with 30. From here, I always subtract when I have variables on both sides. I subtract the variable first for the very reason of what's going to happen here. This one zeroes out because 21 minus 21 is 0, and this one zeroes out. 21 minus 21 is 0. So we are left with 30 equals 30. There we go. Now you can see it. 30 equals 30. This is a true statement. Because it is a true statement, that means that all real numbers are my answer. And if you're like, well, but what does that mean? That means any number is a solution. So like I could say, fine, pi, 3.14159. If I plugged that in, I would end up with the same thing on both sides. If I wanted to plug in 2,476,000, I could plug that in and get the same answer on both sides. Okay, so that's what it means by all real solutions. You may have already seen this as infinite solutions, and that is because if it's all real numbers, then there are infinite all real numbers. And that's how that works. And again, did not mean for it to give you the giant numbers that it did. If you are needing help, come ask. We are happy to help you. Have a wonderful day.